Hi, everyone. Welcome to the Physionic podcast. Today's episode is going to be discussing exclusively protein intake, total protein intake, as well as animal protein and plant-based protein, and its association based off of a meta-analysis, so kind of the greatest form of scientific evidence that we have. So looking at the association against overall mortality, so the risk of death, as well as cardiovascular disease, so that's like heart disease, stroke, things of that nature, and cancer risk. And before I get into this too much, if you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD student in molecular medicine, and this brand, Physionic, is about learning our body. Now, again, before I go even deeper into this, because I do have quite a few notes on this particular topic based off of this study, I'd like to quick at the forefront mention that this may end up attracting a number of vegan or plant-based enthusiasts, and I certainly welcome you to the podcast. However, I would like to have a disclaimer here that just because, and I am going to be reporting some pretty good information for people who follow a plant-based diet, which is fantastic for those individuals. So that's great. However, what I found is that when I release content that's pro-plant-based, people typically take that and they're like, okay, great, wonderful, that's awesome. And then if I post anything which is still in the exact same vein of being science-based, it's based on a study, and that study ends up saying something that might be either ambivalent or it's negative towards a plant-based diet, suddenly people just refuse to accept that science. That's not how things work. You are not a science-based individual if you take the science in one situation and then suddenly turn around and refuse the science in another situation, unless you have a critique of the methods of that paper and you feel like they should have improved in this regard and that regard. That is a fair critique of the science. However, just taking the data at face value and simply saying, no, I do not accept this, that is not a science-based critique. So I wanted to say that up front because this podcast will likely be a positive outlook for plant-based individuals. And if you join the Physionic brand, knowing this moving forward, there may be, I'm not predicting anything, but there may be content that you may not agree with, and it may go against your plant-based mentality. As such, you need to use the same critical eye or the same level of acceptance that you have now, if that's blind acceptance or if that's a critical acceptance of looking at the data and being like, yes, I agree with this. You need to apply that to future content, okay? It gets very annoying to have these conversations with people that are incredibly selective about how they go about interpreting the research that I put forward on the video channel and on Physionic in general. So I know that was a bit of a rant off on the side, but I really did want to point that out because it does get frustrating to constantly have to explain this over and over and over again. Okay, so let's get into this study. So again, this is a meta-analysis, so they looked at many, many, many different studies to come to the conclusion that they did, to show the data that they showed. And this study came out of I believe the British Medical Journal. I believe that's right. BMJ, which is a reputable journal, which is great. So it went through the peer review process and whatnot. So let's talk a little bit about what these authors ended up, how these authors got to the conclusions that they did. And then I'll be covering exactly what those results were and then the conclusions that we can take from that. So the first thing is that we know that high protein diets in general are great for weight loss, preserving muscle, and increasing strength. That, if that's an animal-based or plant-based, it doesn't really matter. either one will lead to increases and betterment in all three of those main variables. Of course, in other areas as well. For example, cardiometabolic markers like blood glucose levels, blood sugar, and blood pressure, as well as they may decrease blood fat levels as well as decreasing cholesterol. And that's actually more poignant for plant-based proteins, and we may see some evidence of that just coming up. So there's an increased effect that comes from plant-based proteins, and there are certainly many different hypotheses as to why this might be the case, but one of the main ones is due to the actual amino acid composition. And I think we're kind of in the infancy of understanding how each amino acid of the 20 amino acids that are kind of vital, that are just part of our biology, our physiology, that how do these individual amino acids affect us. And a while back, I did some content, which I actually never released now that I think about it. But on Instagram, I posted some stuff about it, but hopefully in the future, I'll actually cover this piece because it was really, really interesting. And they looked at branched chain amino acids. And specifically in that study, which was incredibly comprehensive, they looked at how branched chain amino acid impacts our food consumption. So it was really interesting because they ended up finding that certain amino acids actually dramatically increase food consumption, leading to, in this situation, it was mechanistic, so they were looking at animals, but these animals started consuming considerably more when they had particular amino acids present and when they were deprived of other amino acids. So I hope that in the future I can publish some content based off of that study because it was really, really interesting when I was going through it. I don't actually know why I never released any content on it. It is a pretty overwhelming study, though. It's really huge. So, and then on top of that, not only is the composition of the amino acids, the ratio of these different amino acids different in plant-based proteins, but also the accompanying nutrients that come along with that. You're going to have typically, almost always, increases in certain micronutrients, if that's in minerals or in vitamins, which you're not going to find specifically in certain proteins. Now, certain animal-based proteins. So like meats might have certain vitamins, but may be deficient in other vitamins and so on and so forth. So in the past, other studies have shown that there is a positive association between animal proteins and cardiovascular disease, meaning by a positive association, that's not a good thing. That means that if you have increases in animal proteins, then you have increases in cardiovascular disease, higher risk of heart attacks, heart disease, things of that nature. So is that going to necessarily be the case? Now, these were individual studies, and the research was pretty back and forth. You had certain studies that showed yes and certain studies that showed no, and most likely that's because of the methodology and or the participants that they ended up studying, so the people that they ended up studying. Maybe people who are prone to cardiovascular disease at the age of, 63, as opposed to people who are 45. Something along those lines. So you have differences in the participants. Okay, so how did this particular study, which again is kind of a combination of many, many studies all put together and looking at the data of each individual study and kind of putting that together into an analysis? Well, they looked at 57 studies initially, and then they ended up excluding 25 because some of the participants in those studies were patients with renal disease, some were intensive care patients, some were at the end stage of cancer, some had different reporting methods. So there were a number of different reasons as to why they excluded certain studies. So 25 studies were excluded, leaving us with 32 studies that made up this meta-analysis. So that's still a pretty large sum of studies to look into. And the studies had to have certain things for them to be included in this meta-analysis. You don't want to just look at anything. You don't want to just look at, for example, just protein intake and not take into consideration where that protein intake comes from, as well as maybe their caloric intake, how much body weight they had. I mean, base things that kind of need to be controlled for to actually get some idea. Now, they weren't exactly able to control for every single variable, but they were able to control for certain variables. So one of those is like the participants couldn't be adolescents, so they had to be at least 19 years old and could reach up to 101 years old. So a huge grouping there, of course, but over 32 studies, that's going to end up washing out. But the point being that you have a bunch of adults in this situation at varying stages of their adulthood, but still adults. They ended up investigating 71,000. Yeah, I think I've got a typo here in my notes, but I believe it's 71,000 participants. Either way, it was at least thousands of participants that were part of this meta-analysis. Not that they came in, this is just looking back at the studies that have already looked at all this information, gotten the results that they've gotten. So each study had to be prospective, meaning that they ended up employing some sort of intervention, meaning that they told them, hey, consume this amount of protein, consume this type of protein, whatever it might be, and keep a food journal or whatever it might be. And then they had to have a follow-up. So they had to, put the intervention in, and then after X amount of time, they did a follow-up where they actually did the testing, if that's in cardiometabolic markers, like testing cholesterol levels, blood glucose levels, things like that, interleukin-6, whatever it might be. And so the follow-ups were between 3.5 years, so a decent amount of time there, all the way up to as much as 32 years later, following these particular diets. Now, certainly there are limitations to studies like that, which I'm not going to go into at the moment, but overall there can be limitations. Well, there are limitations to these kinds of studies, but they can still be pretty informative. And the last thing is that they did investigate, or the last thing I'm going to point out is that they did investigate both men and women. So that's a great thing to look at. Okay, so now let's look at some of the results. Of course, there are more specifics, so I will have this study linked for you so you can go into it for yourself and read into it for yourself. Now, certainly some of the statistical analyses are pretty in-depth, even beyond my knowledge, because I am not an epidemiologist. However, I do understand them to a pretty base, maybe even an intermediate degree. So looking at the results, they looked at total protein first. So they mentioned that total protein intake and its impact on all-cause mortality, so death from really any cause whatsoever, so just death in general. And they found that there was an inverse relationship, meaning that if total protein intake increased linearly, then you saw decreases in mortality. So protein intake as a whole then has the idea is then it has an association, a betterment of mortality risk, so decreasing mortality risk. Now, of course, this is not, I'm always going to say this is not causative data, because we're looking at all associations throughout this study. That's what they're essentially saying throughout this meta-analysis, that these are just associations. So the next thing that they looked at was animal proteins and all-cause mortality, and they found that there was a mix of inverse relationship, which is the same as what I just mentioned, where you see increases in animal protein, you start seeing decreases in mortality, but with most of the studies showing no relationship whatsoever. So if you saw increases in animal proteins, it had no positive effect, but also no negative effect on, if there was an effect. At least I should say no positive association or no negative association in that respect. Finally, plant proteins, looking at all-cause mortality, and that was, again, an inverse relationship or no relationship. But most of the studies, from what I remember, had an inverse relationship, so that's a good thing to find. Then looking at protein, so total protein on cardiovascular disease risk. So all the proteins, so looking at all proteins, led to an inverse relationship. So again, increases in total protein, therefore decreases in cardiovascular disease. Then looking at protein and cancer, total and plant proteins showed an inverse relationship. So again, that's a positive for plant proteins. However, I don't think that there was any association, good or bad, for animal proteins. So then they did Actually, to go into that a little bit more, so plant proteins consistently showed an inverse relationship against cardiovascular disease, mortality, and cardiovascular disease and mortality. There's a more consistent relationship with plant-based proteins. Total and animal proteins showed no real relationship. While there were a few studies that showed an inverse relationship, for the most part, there was no real strong relationship between those two. So it seems like plant proteins at this point seem to be a better way to go. And then cancer was not associated with any protein, and that's including plant proteins. Most of the studies found that there was no association between plant proteins or animal proteins and total proteins on cancer. Even if you might have like one study or two studies that do show a slight inverse relationship, that's still not enough grounds to then assume that that is going to be the case if you've got 12 studies that say that there's no relationship. Okay, so then they did further analyses on a dose-response relationship. What that means is that if you increase the intervention amount, so let's say initially it was just, hey, you need to consume this type of protein. Let's say you need to consume plant-based protein for the next 3 years, and we're going to follow up after those 3 years, and we'll be able to measure how you're doing. Are you dead? That would be falling into that mortality cause. If do you have cancer? Do you have cardiovascular disease? Things like that. And now they're adding another element in that they're trying to stratify these studies based on the amount of consumption that they had. So not only you should be eating plant protein in this intervention, but we also want you to consume X amount of plant protein. And therefore now this meta-analysis can stratify based on the amount. So if we have increasing amounts of consumption of plant-based proteins, then what happens to these different variables? Again, cancer, cardiovascular disease, and all-cause mortality. And they found that with a 3% increase in consumption of plant-based proteins, there was a 5% decrease in all-cause mortality. So again, some good evidence there, some good associative evidence there. Then they found non-significant decreases in mortality, cardiovascular disease, and cancer with total protein increase. But I was looking at the data, it's looking at the actual graphs, and they've got two different analyses here. And this is where I'm going to flounder just a little bit because I am not a trained epidemiologist or statistician, but they looked at a linear model, which literally just looks at points, like a series of different data points, and then just creates a straight line. And then they had another model, which now evades my memory in terms of what it's called, but it's a more rigorous statistical analysis, which is not a linear model, and it tends to follow points. So it actually creates a curved line, and then you're able to determine the overall hazard or the overall odds ratio. That's what these different terms are called for statistics, to show is there a benefit or is there a negative with increasing levels of each one of these interventions. So although they kind of plainly explain things in the actual text, if you look at the graphs, there's a little bit more information there that we can glean. So with further analysis, they found that there was a non-significant decrease in mortality, cardiovascular disease risk, and cancer risk with total protein increase, which goes in line with what we were talking about earlier, that with, for the most part, that you see an increase in total protein, then you get a decrease in these various factors. Now, this is based off of this new analysis, so that is not taking into consideration the analysis that I've been talking about in the past. So that was the previous analysis, a linear analysis. Now we're looking at this new multivariate analysis, which is more complex. I do not have the expertise to explain to you all of the details of that multivariate analysis, but I'm just reporting on what I'm actually seeing here. So with that, once you get to about 23% of your total calories consumed that are now proteins, there is no decrease. There's no longer a decrease in these different factors: cardiovascular disease, cancer, or all-cause mortality. Now, here's what the interesting part, because they cut it off. They cut off the graph at about 26% of calories coming from protein. If you look at that, if you look at the graph, again, the paper is going to be linked for you, so, and it's open access, so you can read it for yourself. I'm looking at the last figure there. You start seeing an upward trend. So I wonder, and this is certainly not something that's talked about in this paper, but I wonder if that upward trend were to continue if you went beyond 26% or 23% of total calories. If you got up to 30%, 35%, 40% of total calories, would you start seeing a direct relationship where you have a non-inverse relationship, meaning that as you continue to, the initial increase in protein consumption leads to a decrease in these cancer, cardiovascular disease, and all-cause mortality. But as you continue to increase protein, eventually that effect starts to dissipate until eventually it reverses. So that if you continue to consume high amounts of protein, then there's a relationship that leads to a bad outcome, where you see increases in cancer risk, increases in cardiovascular disease, and increase in all-cause mortality. Who knows? That is pure speculation on my part. Looking at the graphs, I do wish that they had continued this extrapolation, but I assume that they were probably pretty limited by the studies that they had at hand. So, but let me continue on from there. So with animal proteins, so I was talking about total proteins there. Now with animal proteins, there's initial decreases in mortality and cardiovascular disease and cancer with just like you would with the total protein increase at 8% of calories, which is really low protein. I mean, if you're talking about like a 2,000 calorie diet, I think that equates to like 40 grams of protein or something along those lines. So if 8% of your calories come from animal proteins, then you see decreases in mortality, cardiovascular disease, and cancer. However, once you extend beyond that, once you get to 16 or 20% of calories, you really see an upward trend. So meaning that relationship flips again, just like I was talking about earlier, where at the very least, and I think that it's not statistically significant, although I believe from what I read, the p-values were at like 0.07 or something along those lines, or 0.08, which is incredibly close to statistically significant. So assuming, we'll just take it at face value what it is. It seems that at best there is no effect, that there's no, no association between animal protein and decreases in cardiovascular disease, cancer, and all-cause mortality. And at worst, that it tends to be associated with increases in all three of those. But more specifically with, if I'm looking at it now, it seems like the most is with cardiovascular disease, which is actually in line with what they mentioned at the beginning of the paper, what other studies had found as well. So there's at least an association, most likely with increases in cardiovascular disease from animal proteins. That may not necessarily be the case. It may not matter. It's not going to be an improvement, but it's not going to make it worse with cancer and all-cause mortality. In terms of, again, we're talking associations. Now, let me go into the plant proteins, and then I will finish things off. So the plant proteins led to a reduction, and this goes in line with the linear analysis that I was talking about earlier. This more complex analysis says that plant proteins reduce all-cause mortality, cardiovascular disease, and cancer, or at least associated with, at all amounts. So only at 7 to 9% of calories for cancer. So less of an effect, or less of an association, I should say. I keep getting that mixed up. less of an association with cancer, and actually there tends to be an upward tick again. And that's the strange thing, that the same thing that we're seeing with animal proteins, so that an overall, and actually also the case for total proteins, that if you consume more and more and more protein, that the inverse relationship that we want to see, that would decrease, that would be associated with a decrease in cancer and a decrease in cardiovascular disease, et cetera, that tends to reverse. Also for plant proteins. However, that is not statistically significant. So we can't, again, they don't extrapolate outwards. And what's weird, and I wish that they hadn't done this, but they actually cut off the graph for plant proteins at 11 calories, or 11% of calories. And you can already start to see that upward trends of that inverse relationship starting to shrink, eventually getting to a point where it has no relationship. And I wonder if they had extended that, because for animal proteins and for total proteins, they went up to over 20% of calories. But for plant proteins, they only went up to 11% as the very end of their graph. So if they had shown, 20%, 25% like they did with the others, I wonder if we would start seeing a climb where just proteins in general have an association with worse outcomes. So seeing greater risk with cancer, cardiovascular disease, and all-cause mortality. But as a whole, it seems like out of all the proteins, so if you're looking at total proteins, or if you're looking at animal proteins, or if you're looking at plant proteins, it does seem that plant proteins are at least the best of the three scenarios that we've been discussing. So now, as kind of final word here real quick, is that this is just associative, and there's certainly good evidence. I mean, that's certainly good evidence, but we don't know the mechanisms. I mean, you can certainly speculate, right? And I mentioned earlier before that the plant proteins, I mean, think about it, right? Where are you getting your plant proteins from? You're getting them from beans. You're getting them from all these different, obviously, plant sources, and therefore you're also going to be getting tons of micronutrients that go along with that. Increases in fiber, for example, which has been also separately implicated at reducing cardiovascular disease risk. So it could be any number of different factors, but overall, the point being that something that either the plant protein composition itself or something that comes along with the plant proteins tends to lead to better outcomes, or is associated, again, the big word there, associated with better outcomes. That does not necessarily mean that it's causative, that if you were to maintain every single variable the exact same for yourself and then just switch plant proteins with the exact same amount, that you would get this benefit. We don't actually know that for a fact. We just know that there's an association. Although, if I had to guess, I would imagine that adding plant proteins into your diet and replacing that for some animal proteins would certainly be beneficial, because of all these micronutrients that you might be missing with the animal-based proteins. Now, I realize that's not going to be all that helpful for people who are, really diehard animal protein fanatics. You can still be healthy and eat animal proteins. There's many, many examples of that. That's not the issue. And again, this is all associative. But certainly I wouldn't stick my head in the sand and just say la 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 la. If somebody's telling me, hey, plant proteins maybe have added benefits that animal proteins do not, because I firmly do believe that that is the case. Again, just to revert back real quick to end this to my earlier rant about plant enthusiasts. Please do not make the mistake of thinking that plant proteins are then superior for every single function on planet Earth. Animal proteins certainly have their superiority in certain areas. But for these three associations, it seems that plant-based proteins have the edge. And whatever negative outcomes come from overall consumption of protein, it seems like plant proteins take longer to get to that point of getting that reversal of that inverse relationship that we want to see. Okay, hopefully you found this informative. Hopefully you found you got some information out of it. Please don't run with this information and think that this is the end all be all, but certainly take solace. This is good preliminary, or I wouldn't even say preliminary, it's good evidence that plant-based proteins may have something about them, or a series of things about them that are positive and may have a causative effect, but we don't know that from this study, but at least have an association with better outcomes in these three markers. Okay? All right. Well, that's what I've got for you, and I hope to have the absolute pleasure of speaking with you in the next one. Have a good one, guys. See ya.